Yeah, I just want to say hi to everybody. Welcome to the DDI seminar for Professor Sayjel Patel. And we're very happy to have him as a part of our seminar series. I was very lucky to know Sayjel by co-teaching an Introduction to Design course at SUDD many years ago, and was very inspired by his creativity, ideas. Later on, he moved to Dubai and became a founding faculty member at the Dubai Institute of Design Innovation. And now he's back to Singapore to run a company he co-founded, working on computational design for architecture, and just fantastic. And I just want to let's welcome Sayjel and to start his talk. Sayjel, please.
Thanks for that awesome introduction, Jiangxi. Let me just share my screen.
Go ahead.
Okay. Yeah, so I'm Sayjel. I'm very excited to give this talk today about ML for sustainable building design. It's really exciting to be back with SUTD, even though it's in like the cyberspace format. SUTD is in my blood, and I'm really excited to share some of my experiences since I moved from SUTD and then moving back, like what I've been up to with the community. So I'm really looking forward to that. So I'm the CTO of a company. It's called Digital Blue Foam, and it's based in Singapore. But our team is global, so we have members of our team around the world in I think 10 different countries, different time zones, and also customers that are all over the world. So we were conceived maybe over 4 years ago, but really came into our own since COVID times. And so we've evolved in this way where we're very working remote, working asynchronously, and it's been very exciting. So today, basically I'm going to talk about 3 things. The first is I really want to share how we think of sustainable design and how that could enable new ways of thinking about actually addressing the challenges of climate change by being able to frame it in a very clear way. And where do we think as a startup, ML, because the title is ML for sustainable design, where ML and other technologies fit into that vision of sustainable design. And finally, I want to share also a bit about being the co-founder of a startup and also our process. So I'll give some insights also on what to be a startup, create a context of a startup, and then maybe we can also have a discussion, how is that different than say academia or in other types of venue to do research. So just a little bit before I get into it, a little bit about me. I'm trained as an architect originally, and I sort of had this path where I've had too many hats. I was graduated as an architect, then I went to graduate school, got into research, then I got into teaching, and now I'm back as a tech co-founder. And so it's kind of funny because I've been teaching for almost 6 years now in academia. But still, I feel nervous like talking in a venue like this because you know, I feel like gradually trying to open up what I'm doing as an architect to a broader community, and also trying to learn from other communities and how that can influence the work. So kind of the way I like to think about my career progression is like, first I was sort of like a dolphin as an architect, in that you know, dolphins are very smart, but only other dolphins can understand what they have to say. And then as a graduate student, being an octopus. So trying to do a lot of things, but then just being like mediocre at doing a lot of things. To being sort of like a duckbill platypus, where you're just trying to do a few things well, but you look silly doing it. But ultimately, the aspiration for me from my career is to be like the flying fish, and that I can successfully manage 2 things, which is being both a designer and a technologist, and be elegant in 2 worlds. So just like the flying fish looks amazing underwater or flying in the air, like that is the dream. I'm still in like the duckbill platypus stage, but this is the aspiration. So yeah, so like just getting into the talk, I want to first share this image I came across on Reddit, because when I first saw it, it was very striking to me in a couple ways. It like kind of conjured some very interesting emotions that I wanted to share with you that kind of relates to why I have a startup and why are we pursuing this challenge. So this is an artist rendering of Singapore in 2042, where they imagine that, okay, climate change is taking its course. The sea level has risen. But when I saw this image, I actually thought, wow, this is amazing. People have come up with solutions. They've built this seawall, and they're trying to solve the problem. So in some sense, I feel very hopeful when I see this. On the other side, I'm like, you know, is this enough? Can we really overcome the force of nature, or is this something that's futile? You know, but I think ultimately I see this as a very hopeful way of thinking about the future, because I think we're all thinking about the future right now in our work, how what we're doing relates to solving a lot of the problems, challenges that are going on, and like not just thinking about it or being overwhelmed, but like how can we actually do something about it? In my blood, like fundamentally, I'm an architect, and so when we're talking about climate change, our image industry is deeply responsible for what's happening. So 40% of all carbon emissions, and this statistic should be familiar to anyone that's in architecture, but for all the engineers, 40% of the carbon emissions come from buildings, from the operation of buildings, from the construction of the buildings, from the materials, the embodied energy that makes up buildings. And so really the building industry has a huge part and a huge responsibility to make a change to help us avoid this point of no return that the UN has pointed out, that by 2030, we have to drastically make some changes to avoid temperature changes. And so just by decarbonizing the built environment, you can make a huge dent in this, more so than any other industry. And so thinking about my startup, really it's about how can we accelerate this decarbonization of the built environment. This is what everyone, I think, should be thinking about. This is the big challenge, big question. And if you look at the building industry, and you compare it to other industries, such as like IT, finance, agriculture, manufacturing, it is the least digitized of all of them. And so it has to undergo a very radical innovation in terms of transforming itself to be able to take on this huge challenge that it's also causing of carbonization. And so still we're stuck with this kind of process, a very linear process in which the majority of buildings are created, in which different parts of the process are bottlenecked from one another. So you would have like a real estate development, then design, then you would have engineering, and so forth. And so the real problem when we're thinking about the use of data and the design process is that each of these steps is a silo in which information is lost. And the building industry does really bad at, okay, we've created a new project, or we've constructed something new. Let's learn from it and improve the next one. The building industry is terrible about that. And so what we imagine is in the future, a more operating system approach for construction. And so this is really like the vision behind our startup, which is called Digital Blue Foam. And so really our goal is to be able to enable this transformation through building a digital platform that is open and intelligent. And so just a little bit of where we are. We've built an online tool that designers, real estate developers, consultants can use to do feasibility studies. And the reason why we focused on this is because often this is the point in the first part of the project when the design is conceived. This is where many of the decisions which affect energy use and the kind of quality of the design are made. So you could have like a fancy type of glazing system, like a very well insulated window. But if you've oriented your building incorrectly or missed some of the fundamental kind of decisions of a design, these kind of like applied solutions don't have the same kind of effect. So we just have to get the basics right. So yeah, so today's talk, the first part is really talking about our creative process. So I like to share this. I don't know if you know this movie, Apollo 13. Jenksy, you know this one? Yeah, so this is how we imagine, like how we work as a startup. So in this movie, the spaceship is trying to return to Earth, but their air filter is broken. So they just have to find whatever's on hand and come up with a solution to solve the problem. And so the way we work is we're really pragmatic. So whenever we try to test something or build a new feature, we try to build it as quickly as possible and get in front of one of our users to get feedback. We do this relentlessly. And so the kind of idea is like we need to figure out what is actually like has value in the market quickly rather than spending a lot of time and then finding out it doesn't have a use. So this is like our creative process. And okay, so just to take a step back, so we talk about creative process and sustainable design. Now I'll talk about what sustainable design is to us. And this is not my idea. I got this from an architect named Craig from Toronto, but I thought this is the best way to think about sustainable design. Craig says it's three things. Sustainable design is about harm reduction. So what can we do to reduce the harm we're causing to the environment? Regeneration. So how do we repair the damage that we've already done? And the final one is adaptation. How do we live with climate change? How do we live with, okay, we can't fix things. How do we just adapt to the way the world is? So where we're focused on a company right now, as a company right now, is really on the harm reduction. Like how can we reduce carbon emissions from the built environment? But the next two steps are also very important. But today we'll kind of talk about harm reduction. And so when we talk about decarbonization, as a company, there's two core metrics we like to look at. One is at the urban scale and one is at the building scale. And so when we think about decarbonization, what's very apparent is the solution to the problem is right in front of us. So being in Singapore, it's hard to see this, but I grew up in the suburbs in North America. And just by living in a dense city, like Singapore, you already use 1/5 the energy, or you have 1/5 the carbon footprint as someone who lives in the suburbs. So the solution to the problem is density, but then the question is, how do you build density well? How do you make it humane? How do you create density in a way that's very livable, has amenities, and that people can live well? And so that's an important question, is how do we do urban design? The second is in terms of building energy use. And so kind of the core metric I'm hearing is if we can get our energy use per square meter down to 100 kilowatt hours per year, we'll be able to supply the rest of energy for our needs just using renewables. So in Toronto, I know this is like demanded by developers now when they do projects. I want like 100 kilowatt hours or 75. But in Singapore, actually, I don't know if I should say this, but in Singapore, the average is around between 200 and 300. And see, even these buildings that have this high carbon footprint, high carbon and energy use, they're getting these Green Star certification. So it's like total greenwashing. But these are the kind of like the two main things that we can focus on in terms of design for decarbonization. It's a very kind of easy way to think about it. And then the one thing I didn't talk about at all is the embodied carbon in materials. So in the kind of manufacturing materials, there's a carbon footprint, but I'm not going to get into that today. So now I'll just talk a little bit about our approach as a company. And then I'll show how that leads into different projects that we're working on that are using ML to address issues around sustainable design. So I think we've all, hopefully, or maybe not, heard this term agile startup. And basically, it means that instead of having a very long horizon in the way you've planned out your company and your projects, that you work in a very short rhythm of feedback loops in which you're developing features, building products, and incorporating your end user or customer as part of that feedback loop. So you're constantly iterating, using that feedback to also inform the next step in the process. And so if we think of the evolution of what we built, which is like, I found this like last week, but this was like the initial prototype of digital blue foam, which is, I built this when I was a student at MIT. And then to see almost 7 years later, now it's like very professional. It's not like this just magically happened. This was a lot of hard work, a lot of iteration, a lot of feedback. And when we started, like, we had no skills, we didn't know anything, we didn't even know how to code. We have no ideas. And then now we've been able to grow to 20 employees. We have enterprise customers around the world, and almost 5,000 people have signed up. So we've been very lucky. And there's a lot of hard work in this. So like between those two steps, there have just been like hundreds of iterations of the platform. So here's just like a few, just within like a couple of years, like how much things have evolved. And you can really think of it almost like evolution, like an evolution of a species, the product. And I think that's a really exciting thing of working in an agile way. One thing I would also say for our team, there's this idea of the 15% rule that we try to incorporate into our culture. And what it basically says is that people on the team should be able to have 15% of their time to do whatever they like. And this comes from the culture of 3M, where my dad was actually a scientist at 3M, and he was able to get 15% of his time to work on whatever projects they want, or just do whatever they want. And this has led to many game-changing products from 3M, from like Post-it notes, or the one I showed here is there was actually a scientist who didn't know why moths were following him home every day. And it was actually something he just accidentally created in the lab, and he was able to come up with this moth trap invention. So just by like leaving this open time, people are able to be very creative and come up with things. My dad just went golfing, but he said that allowed him to just think or relax, and that's how he came up with his inventions. So we try to do this with our team. It's very hard. It takes a lot of discipline, but this is like the kind of culture we want to create, where it's very open. So yeah, so just getting to back to the topic of the talk, I'll now talk about some case studies of like using ML for sustainable building design and real estate. And so here like a lot of like I said, we do like a lot of projects, a lot of prototyping. But from all this work, all this kind of like work, like I won't go into all of them, but all this work, there's kind of like 3 kind of core ideas in which very high level, where we see ML is very helpful. The first is this idea of synthetic ML, which is basically using existing algorithms to create a sort of data set that can be used to train a machine learning model. So I know like something like, say, surrogate modeling is well established in engineering, but this is a very interesting solution for building design, because a lot of the data from the building industry is very poor or incomplete. And so people are looking at this as a way of filling in those data sets by just creating data through simulations. The second way, ML is very important to this idea of sustainable design is just storytelling. So we have so much information about cities. It's being generated every day. How do we make sense of it? How from that data can we get some insights as designers? How can we understand the built environment? How can we create a more livable city, right? And so storytelling is very, very important, especially when we're thinking about the city level. So yeah, like I think, yeah, this slide just shows 2001 Space Odyssey. Like, you know, data is kind of like stupid, right? So how do we make that into knowledge? And so that's where ML is offering some interesting opportunities. And then finally, the final like kind of big idea of like how ML can be applied is this idea we found is called augmented intelligence. So for us, this is what AI is using algorithms to support a human as they make decisions within the loop. And so what's really important to this is this idea of interaction temperature. And so when you say a interaction temperature is really hot, it means that the time between when you actually execute a command and the feedback is very short, it's within seconds. So just imagine, say something like spell checking or Grammarly. What if you had to wait 1 minute to get that feedback? It wouldn't be useful at all. And so where ML is like very interesting for design tools is that now we can embed simulations. And so as you're designing or modeling, you can get instant feedback in terms of the performance of the design. So yeah, so like at high level, those are like the three kind of ways we're thinking about ML. And then now I'm just going to show some projects that we have worked on the team. These are very much in progress. And just to show you the kind of range of things that we're working on, and also to show how these kind of three principles that I just mentioned, how that plays out in terms of kind of experiments that we're working on. So the first project I'm going to present is called Intelligent Architectural Briefing. And so architectural briefing is the process in which a landowner or developer, they give a document to an architect about what type of building they want. And so with this experiment, we were looking at, can we predict what should be built in the site based on OpenStreetMaps data? So just by analyzing or training a data set on OpenStreetMaps of what exists currently, can we fill in, if there's a new site, can we predict what would fill into that lot? And so we looked at two types of data. The first was building attributes data. So things like, what is the use of the building? Who are the tenants? What are the areas? So like numerical information and attribute information about the site. The second was the building footprints. So the actual geometry of the building. Could we look at, you know, if I have a site, how do we fill in that site in terms of a footprint? And so this is sort of like the workflow, or this was the workflow, where you can see that we start from the same data set, which is OpenStreetMaps. And then we look at attributes and geometry. We train two different models, and then it comes up with a design brief that informs a conceptual design. So this was our first foray into machine learning, and these were the results. They were kind of interesting, but basically what happened is it sort of like averaged out the data. And so the results looked interesting, but it was not coming up with something creative or something unpredictable in terms of the types of designs it was suggesting, which is, I guess, to be expected. But yeah, so that was our first foray into machine learning as a company. The second project I'm going to present is about neighborhood quality score. And so this one, it looks at, again, OpenStreetMaps data. But then the question, can we present to the user some metrics, some descriptive metrics to tell them what is the quality of a neighborhood, and also to inform them how can they actually make that neighborhood better. And so this is a new feature we've rolled out, and basically it looks at two things. What is the kind of adjacency of different amenities within a 15-minute walking distance to a location, and also what is the urban diversity of uses. And also I say, like, this is not machine learning yet. We're just using sort of statistical analysis. But even this is presented in a way that it's quite interesting. So when you make a comparison of different types of locations, you really get a feedback or sense of, you know, what are the qualities in terms of a kind of pedestrian life of that location. So this is something we've rolled out, and we want to make much smarter in the future. And so yeah, that's a area of continued exploration. The next project I'm going to share is called Personalized Generative Design. And so this project, we were looking at ways that we could engage designers who didn't know how to code. How could they create their own machine learning models and deploy them into our platform? And so this is sort of inspired by Runway ML, if anyone's heard of that, which is a platform for designers to just exchange different ML models. So we were playing with the idea of, like, could we make this for the building industry? And so we presented this at the Cadria conference last spring. And so we rolled it out. So basically the process is this. Architects already have a bunch of software that they can use. And so what we were able to do is we're able to use that software to allow them to create data sets. And then our workflow allows them to use that to train models and then also deploy them within our platform. So I'll just give a kind of example of what this would look like. So this project was looking at the design of park and walk districts in Panama City. And basically the idea is, can we consolidate all the parking within a city into like one or two lots? And then all the space that you've alleviated from that parking load, can you redevelop it into a walkable district? And so basically we need to look at two things. One was predicting what is the parking capacity of a city. And so we're able to create a script that did different parking layouts for an outline and able to predict a capacity for a shape. And we were, hello? Yeah, so we used that model that was predicting parking capacity. We were looking at walking distances and then how we can consolidate them on this site. And basically we were able to analyze all the parking lots and then propose a new development in which they were consolidated. Yeah, so that was like a very interesting use of this idea of a designer had a project in mind and able to create their own model and deploy it within our platform. On the team, we've also been using the same workflow to develop some other applications. So there's two. One was, and this has to do with building performance. So remember I was saying that it's very important to have a very fast interaction temperature. So we're looking at two things. One is daylight autonomy, which is a way of measuring what is the daylighting for a building floor plate. So how much do you actually have to use electricity to light an interior space? And so the input is the geometry and orientation of the building, as well as its glazing ratio. So like the design of the windows. And then from just those inputs, this model can predict within 1 or 2 seconds what is the daylight autonomy score. The other simulation that we're building is predicting wind comfort of pedestrians. And so we're using a CFD or a script that uses CFD to make predictions based on different city configurations. And so this is something we're also working on. But I think kind of with this project, what's really innovative is the workflow of being able to create your own machine learning models and implement it in the tools. So some of these are very, let's say, like very straightforward, but what we imagine is more sophisticated analysis or specific metrics could also be deployed with this based on these scripts. Okay, and then the final case study that we've been looking at recently is looking at semantic ML. So what we find is there's a lot of, say, non-spatial data about the built environment. And so if we look at different types of social media or apps, there's a lot of reviews that are geolocated about places in the city. And so in this project, what we were looking at is, could we mine these data sets and then using natural language processing, come up with a kind of summarized review of people's opinions about a location. So this is a project we're very excited about. We just started working on it. But here's sort of the results. I think this one, we summarized like 60,000 Airbnb reviews. So this was the paragraph that it was able to create about Novena. And so you might ask, okay, why is this interesting? I already know Singapore. For a lot of architects, you're doing projects that are not where you live. And so this allows you to really understand what's the kind of local context like. What were the types of buildings? What do people do? What's the quality of life? So this is opening up other interesting questions for us, right? One way we're also thinking about this is in terms of real estate prices, or looking at looking at sentiment also. Could we use sentiment to evaluate these descriptions to understand, is this a good place? Is it like, what kind of place is this? Yeah, so those are kind of ways we're looking at this. But yeah, so there I just showed some different projects that we're working on using ML. Basically, there's two types of projects. One that's like looking at the urban scale, how we can measure or understand the quality of the urban environment, which relates to the question of how do we do density well? How do we build density well? The other was in terms of performance. So the CFD and the daylight autonomy, how can we site buildings in a way that reduce their energy use? So this is just like a few things we're working on. But yeah, it's been very exciting to present that. And there's also, still a lot to do. We were just talking about harm reduction as like kind of sustainable design strategy, but there's a whole world of discussion around, say, regenerative design. So how can we regenerate the environment or even like adapt? And so there's very interesting problems that come out of that. Yeah, and I mean, I think also, being an architect, like putting my feet into this ML world with my team, is very exciting. And I think, I just wanted to share this slide because I think things are really changing, because now architects, we don't need to know the math to use these algorithms. I know the engineers might be like skeptical of that, but we don't have to do the number crunching. We can just explore applications. So if you look at any sort of architecture conference now, it's all ML, which I think is very exciting. But maybe this is something we could discuss when I take questions. And then the other thing I wanted to like kind of raise a point, how is the process of a startup where you can see here too, like our projects are very fast. Like building a prototype, test it, see if it works, present to a customer. Like how does that differ from, say, an academic approach? Because in some way it's similar. In some way, like I think there's things to learn, and how they could collaborate together. I think that's another question. But yeah, I mean, yeah, happy to take questions. I hope this was interesting. I hope my story was interesting. I would also just like to share, we're having a product launch on the 21st of September. So if anyone is interested in what we're doing, please feel free to join us for that, where we actually show you the product. But yeah, I'm happy to take questions now.
Okay, Sayjel, thank you so much. Very inspiring. Not just the work you do with the DBF and the software, the project, but also your personal thought process and your experience are also very, very inspiring. Thank you. So let's open up for the questions from the audience. But if you don't mind, I'd like to kickstart asking the first question.
Oh no!
So the audience can have their questions in the chat box, right? So and if you have any question, you can write it down in the chat box, and we'll call you in sequence or later on. Okay, so my question is, you know, the title you sent to me was machine learning for building design. But what you have been doing actually goes beyond that. And certainly you show your machine learning capabilities in DBF platform, but at the same time, you also demonstrated some generative and prescriptive capabilities, and which are actually about machine creation. And is it more accurate to say that you're actually working on machine creation and beyond machine learning? Because machine learning is about recognition, pattern recognition, right? And see what's in the data.
Yeah.
But you're actually building capabilities for machine creation. Is that accurate? More accurate?
What's machine creation? What is that? I've never heard that.
You're actually simulating and generating and structures using your software, data-driven algorithms to generate new structures, new space designs, and new car parks, which never existed, right? So your system actually is a generative, it's a creative.
Yeah.
Right. So it's a machine creation in my view.
Yeah. I think where I've learned the not to do is there's no silver bullet, right? So that's why we think, and I didn't talk about it at all, but we spent so much time on the UX and then implementing a lot of solutions with different capabilities within a user experience, rather than having one silver bullet that just will generate a building. Because we've learned the hard way that it's like it's not the right approach, if that makes sense.
Got it. You're very humble. Okay. Okay, let's get some questions from the audience. Anyone want to ask a question? You can just raise your hand or turn on the mic or type it in the chat box. Marija, go ahead.
Hi. It was really exciting to hear what you're working this moment. So lately I was exploring more about traffic noise and recovering a neighborhood from traffic pollution. So I was thinking, do you have any thoughts about making algorithms where it could be more easy for architect to get the right data and information, what is currently traffic noise of that, and how good with architecture and recovering from some installation and the public space could help for improvement of a neighborhood.
Thank you for the question. It's a good question. Might I ask though, like, where are you getting your data from right now?
Well, that's what I'm trying now to do, because it's a bit hard to get the right data. and in this moment it's gonna be only a local measurement from a specific point, and trying to get information, but it's not. It's very hard to do, like, some kind of expagation, because there are not a lot of data.
I think we've looked at this before, and where we got blocked is because Google has really excellent data about traffic patterns, right? Yeah, when there's a lot of traffic.
Noise and a way of noise is moving through space. It's,
yeah. So we were looking at this, but we got blocked in trying to get the data set. So Google thought, okay, could we correlate this to traffic? But even Google is not. They just give you like a kind of pixel map of traffic. They don't give you the actual data set. So that's where we sort of got blocked on that idea. But if you have ideas of where we can get data, we were very keen to know about that.
Sorry.
So we have a question from Hazel. Hazel, would you like to speak out your question?
Hi, can I be heard?
Yep. Hi, Hazel.
Yeah, so I was just very interested in, like, because you showed the base of your project, how it started and where you ended up, and it was pretty amazing. I was just curious about how was your process in, like, creating the application, because, like, you have like an application in mind that you used as a base and then started adding in stuff before really going into making your own application from scratch, or do you really just start from scratch and just kept building on with all the pains? Yeah, so I'm just curious about the journey, because this is kind of related to my school project. Yeah, so I was just curious and like some tips, I guess.
Yeah, thank you for the question. I love that question. Surprisingly, what we originally visioned, like in fundamentally, it's the same like product as where we are now. It just became so much more sophisticated. And what I never imagined is how much persistence it takes to have a startup and build a commercial project or commercial product, because there's so many chances to give up, and it's so hard. Even getting like your first customer, like, it's extremely difficult. And the only way to break through that is just to be very persistent. And also you have to be very confident in what you're doing, because you'll get a lot of people telling you like it doesn't make sense, or like it doesn't work, right? But the persistence is like the most important skill. But we had a very clear idea from the start, but it's like it's becoming more and more sophisticated, more refined. I think also though, when I look back at our the initial prototype I did when I was a student, there was a very sophisticated sense of aesthetics about the user experience, even in that initial version. And so that's the thing I think is actually missing from a lot of say like tools or like school projects that I see out there, is that it's thinking in a very say functional or so I don't want to say that's janksy, but like very engineering way. But we also need to think also about the user experience, and aesthetics play a big role in that. So just something to think about.
Okay, Thomas.
Yeah. Hi, good to see you,
Hey, Thomas.
Hi, everybody. So
Good.
those who don't know me, I did my PhD at SUTD. Now I'm a tenure-track professor at the ICD in Stuttgart. Thanks, very cool project. Great to see what you've been doing. So my question is, who are your clients? Specifically in the context, right? Is this more actually, is this automating part of the tasks of architects or engineers, or is it supporting the real estate industry? So yeah, but that's the direction of my question.
Yeah, that's a very good question. I'd say in the way, like just like the way you do, like the way we've set out our business is that we're starting with like very big customers, and then working our way, like the vision is like later on, that's when we'll go for like individual architects. but our main customers are very large consultants, which maybe have over 5,000 employees that have an architecture division, real estate division, construction division, engineers. And so their sort of pain point is they have so many projects, but they want to boost their in-house design team. So they want to be like, top firms like KPF. They want to have that caliber. On the other hand, too, they might also have a lot of very, what's the word? Like very mundane projects, like warehouses or industrial buildings that are like, need to be built, right? And so this is where they see the use for our platform. But really, like our kind of plan is to go into the SaaS model where people can sign up. But right now, like 99% of our revenue is coming from enterprise.
Thanks. That's actually very interesting to know, and also aligns with what I see, that a lot of these big integrated companies are building up their parametric capabilities.
Yeah.
Okay, so we have a comment from Jimmy in the chat box, but it doesn't look like a question, right? And Jimmy or anyone want to ask the next question? All right. I guess there's no more question now. But Sayjel is always reachable, right? On LinkedIn or email.
Yeah.
If you're interested in collaborating with him, certainly he's available. So
yeah.
Sayjel, you want to say more words, or we conclude the session?
Well, yeah, I would just like to thank you for this opportunity, Jiangxi, to speak as part of your seminar. I really look up to you a lot. I think you're one of the most creative people I know. So every time I talk to you, I get very inspired.
I'm flattered. Yeah, thank you. Thank you for inspiring me and all of us again. It's always great to have you around. Okay, so the audience, thank you for participating, especially the ones who ask questions to inspire the rest. So if there's no more question, it's end this session. We'll keep in touch, and Sayjel, everyone.
Thanks, everyone.
Have a good one. Bye-bye.
Bye.